Duplet and Octet Electrons Arrangement. In Chapter 2, Structures of Atoms, we have learned that electrons in an atom doesn't arrange randomly. They are arranged in certain manner, right? Okay, for examples, let's say sodium, and if sodium has 11 electrons, so can you please tell me then what's the electrons arrangements of sodium? Sodium has 11 electrons. 2, 8, 1. Okay, 2, 8, 1, right? Okay, 2, 8, 1, yes. Okay, so the first shell has 2 electrons, the second shell has 8 electrons, and then the last shell has 1 electron, right? The charge on the nucleus and the number of electrons in the valence shell determine the chemical properties of an atom. Okay, so the chemical properties means that how an element react. The chemical property is determined by the charge and also the number of electrons in the valence shell. It depends. This is the valence electron. This is the electron in the valence shell, and this is the things that affect the chemical properties. Okay, we have learned this in periodic table, right? That's what you need to know. So the stabilities of noble gas is due to the electrons arrangement. So group 18 are very stable, and the stability is because the arrangements of electrons. Charge on the nucleus mean proton number. Yes, because inside nucleus there are neutron and proton. Okay, and neutron, the charge is there's no charge, it's neutral. Okay, so then the charge depends on the proton. Okay, for example, so if there is 2 proton, then the relative charge is positive 2. If there is a 3 proton, then the relative charge is positive 3. That is the charge of the nucleus. Charge of the nucleus. It's not the charge of the atom. It's the charge of the nucleus. Yes, the charge of the nucleus is same as the number of proton. So this is about stabilities, okay, of an atom. Stable is the chemical property is affected by the number of electrons or the electrons arrangement. This is electrons arrangements of noble gases. Okay, helium, neon, argon, krypton. Okay, and or you can see here the electrons arrangements 2, 2, 8, 2, 8, 8, 2, 8, 18, 8. For the first elements of group 18 is helium, right? Okay, and helium has 2 electrons. Okay, 2 electrons. Maximum number of electrons can be filled into this shell is 2. Okay, so 2 electron means already full. That is the maximum number of electrons can be filled in the first shell. So 2 electrons is already full. The first shell filled with 2 electrons, okay, which is full already, and we call this duplet. Duplex electrons arrangements. So the outermost shell of helium has 2 electrons, and we call this duplet. Okay, 2 electrons filled in the first shell is called duplet. And then let's see neon, argon, and krypton. Okay, let's see the valence electrons. 8, 8, 8, right? Okay, so if the outermost shell, the valence shell, okay, the outermost shell, this one, okay, and or we call it the valence shell. If the valence shell filled with 8 electrons, 8 electrons, 8 electrons, 8 electrons, okay. So if the valence shell filled with 8 electrons, then we call these arrangements of electrons octet. Okay, this is called octet. Okay, if just 2 electrons in the first shell, then it's called duplet. And for other shell, if filled with 8 electrons, then it's called octet. So that is duplet and octet electrons arrangements. Okay, we know that these types of arrangements make the atom very stable. Yeah, duplet and octet. Okay, it makes the atoms very, very stable.